All right. Welcome back to IT Security Labs, and thank you very much for joining me tonight. And I'm very excited to be sharing with you one more thing that I learned this week. And if you are interested in learning cybersecurity and also just learning it the right way, which is hands-on, no BS way, you are in the right place. This is a live stream, so I'll be showing you how we can break into a system, and above all, how we can detect that attack traffic so we can know what happens on the network. Because most of the time when you go to work, employers are looking for people who can actually detect things, people who know what they're looking at when bad traffic traverses their networks. So that's what we are going to be doing today, sharing with you what does attack traffic look like, what does it look like when you're detecting it, and how can you detect it. And that's really the point here. Thanks BT and Osman for joining. Really appreciate you. So we have a Linux server that is running WordPress. So the first step, we enumerate what ports are running. Then we'll learn about the WordPress service that's on that system. Then we'll try to upload a reverse shell. And to be honest, this is a classic attack. Anyone who is learning ethical hacking, they know get WordPress, you can try to get a reverse shell through it. So there's nothing really special about attacking WordPress tonight, but I'm very excited about the privilege escalation point of this, where we have a Docker container, a Docker service that is running, and we can try to escalate our privilege from a non-privileged user to root using Docker. So that's the highlight for today, and we'll try to see how do we detect that, because that's very exciting as well. Then, of course, throughout the whole time, we'll be trying to understand, or how does this look like in Security Onion? We have a Wazuh agent running. So we have both host-based intrusion detection system, and we also have network-based intrusion detection system using suricata and zeek in this case. For those who are just joining me, my name is Howard, and I've been doing these live streams and having this channel for, I think, at least 3 or 4 years now. And during that time, I've learned a lot of things. And I got some certifications, including the OSCP, CISSP, the Certified Ethical Hacker, and those other certifications. So I do know a little bit about what I'm sharing about because I've been doing it for a while. And I'm just getting excited to share with you because this is how I learn. So if you can learn with me, join me in this journey because I find it to be fun. I have a Kali Linux machine running on 192.168, then some IP address that we'll find out today. And also a Security Onion that's on 192.168.38.10. All traffic is going to be mirrored here. That's what we do for network intrusion detection system. There's a copy of everything that's coming down here, going here. And we are sniffing that, and we're trying to find out, is there any funny business happening there? Is there any malicious activity happening? So Unify Layer 3 switch, that's what we're using. My machine is running on a ESXi, just like this one, and the vulnerable machine I downloaded it from Vulnhub. So go to Vulnhub and type Ganana 1 or just Ganana, and you'll be able to download the virtual machine that I have here. Other than that, I think this is a very exciting live stream. You will definitely benefit a lot from it. So let me go ahead and sign into my Kali Linux machine right now. This is Kali Undercover from 2019. And as you can see, kind of looks like Windows, but it's a Linux machine. This is our attack box. So let's find out what is the IP address here. Our IP address is going to be on 192.168.38.246. So when you try to get a reverse shell, this is where we're going to be going, 246. All right. Our vulnerable machine is running in VirtualBox. So this is what it looks like. You download the virtual machine, put it on a Windows machine in VirtualBox, then mirror all that traffic. So it's running in VirtualBox. If you try to connect to it, it just looks like this. Then you can do a net discover or however you find your IP address. In this case, it's 192.168.38.28. A lot of people ask me hey, so how does what you teach or what you show on your live stream translate to the real world? And to be honest, I'm not in the business of playing capture the flag stuff that doesn't actually get you paid, that doesn't actually help your employer, that doesn't help your family. Because really, that's what this is all about, making sure that your employer gets the skills that are necessary for you to do your job. Your family has you getting a job that actually pays the bills, and also you just get better at what you are doing. So I was looking at some jobs today, and this is from any actually I think that this is a managed service provider or a headhunting company, so I can pick on them. But one of the things that they are looking for, look at this one. It says perform rule tuning. They're looking for you to be an entry-level information security engineer, and they want you to tune some rules for them. What do they mean by these rules? I'll show you today. We actually have suricata rules and Wazuh rules that you can look at. I don't know if you should be doing this at an entry-level job for $58,000, but this is what we have. Centralized logging. Yeah, we do that for a living. This is centralized logging right here. We have all the logs from our system coming to one place. Let's go back. Intrusion detection system. Oh yeah, we're doing that. We have alerts coming. Then SIEM solution. That's the security events and log management system. Then of course, vulnerability management. So what we're showing you today is not some random YouTube video or some guy on YouTube just showing you what's fun. This is actually, if you can do it better, and you can do it better than what I'm showing you tonight, you'll be very good at your security job, and you actually perform and get paid, and also be really productive at your work. So I just wanted to show you that, because it's very important that we know that this is not just a game and we don't do this for fun. It's also helpful. That's why we do it every week. So we start with an nmap minus sv minus sc to 192.168.38.28. I like to scan all ports. So what I'm running right now is I'm running network mapper or nmap against a target machine. In this case, this is our client machine. Let's assume you are testing a machine for a client or that you own. You're like, hey, what's running really? What can everybody see? Or an attacker could be saying, oh, I'm trying to get into this machine. What's running there? This is our vulnerable machine from Vulnhub called Ganana. This machine is host-based intrusion detection system enabled using Wazuh agent. And I can show you in a different video if you're interested in that. Let me know. But it's very simple to set up, forward the logs from any vulnerable machine. In this case, it's a Linux machine to security onion. So we're running nmap right now. According to our job here, job description, we need some centralized logging, meaning we need a central place where we are sending all these logs so we can see what's happening on the system. Well, I do have security onion, so let's go and check out this centralized logging system. So one thing that you'll notice is I'm visiting my security onion here. I also have a video for you to see and how to set up security onion, so you don't have to set it up yourself. Check out my YouTube channel. It'll actually show you how to set this one up. Well, here's centralized logging. We have a problem here. We're seeing a bunch of logs. Starting from this one going down, these are all nmap scans. So when you run a scan, this is what happens. Doing what we're doing here is going to distinguish you from those people who just like, hey, I play CTFs, I know how to attack Linux machines. Then you ask them, oh, what does it look like on the network? They have no idea. If you do what I'm doing right here, you're like, okay, you run nmap, you get a bunch of ET scan alerts from suricata. That's an intelligent person. That's somebody that I want to talk to, not somebody who is just doing CTFs and they have no idea what actually that traffic looks like. So if you run nmap, most of the time it will say ET scan suspicious. MySQL ports will always show up, and Postgres ports. Any database ports that you scan, which if you use a default scanner, you will, these will show up. This is helpful for defenders because if you see these, you know that somebody ran nmap using the default ports and just the top 1000 on the all the ports. And also some of these here. So we know nmap does generate some traffic. Let's refresh that. Then we'll go and check out how many ports did we see and what ports are they, because that's going to be very important for us as well. So right now we see a bunch of enemy ports here. I'm going to open a Kibana page. Then we can look at that one later. All right, and coming back to our Nmap, which is Network Mapper, which is a tool that if you're brand new to cybersecurity and you really want to be in the offensive and defensive security, you kind of need to know. We see that we have port 22, which is open. If you download this machine from Vulnhub, this port might show up as filtered. I had to mess with the machine to make sure that my monitoring and my Wazuh agents are working. So I kind of had to open port 22, but yours might show up as filtered. That's fine. We still have port 22 here, and we probably won't be using it for anything really today other than it's there. We have port 80 and 443. This is classic, or let's say, usually people should not open port 80. They should just leave 443, and 80 should just be closed, because as you and I know, port 80 is not encrypted, so maybe it's not smart to run your website on an unencrypted website that people can see stuff. And I'm going to show you the implications of this. So we are going to actually find passwords to sign into the website that is running here because of the implications of having port 80, which is not encrypted, running. We have a version of WordPress. And I'll tell you right now with a lot of confidence that when I was first starting learning cybersecurity and ethical hacking, WordPress is what you attack. So if you go for the certified ethical hacker, you are guaranteed they'll give you some WordPress website to attack. You go for the CISSP certification, they'll throw you a WordPress website to attack. This is how people learn to attack stuff. So WordPress is by far the easiest thing to break into. And I'll show you some of it today, but there's a lot of videos that I've created here where I attack websites that are running in WordPress. In this case, we have a version 5.4.10, which is very helpful, so we might want to look at that. Our very good friend robots.txt is not allowed this time, so we should not waste our time checking that, but we should check WP admin. So you might be thinking, well, what does this mean? How do we actually do this? You open a browser. You go to the website on http://38.28. First, you just go to the main website. What does it look like? This is how you start interacting with port 80. Is what does it look like? It says, oh, my name is Ganana. Okay, you're not telling me much. Can I see the page source? Right click and view page source. So if you're given a website that's running on any platform, go to the page source here. What you can see on page source is comments. People usually put comments, and comments are going to be usually in different colors. So people will put like, hey, administrator, your password is this. That's mostly CTF stuff. So I'm telling you CTF stuff here. In this case, we don't see any comments that are interesting. Most of this is just, kind of noise. You can also look for any redirects, like here is a comments feed that we're being redirected to. You can go and check those. But in this case, there isn't really anything that is interesting on the base URL of this website. You might have to spend some time there. But according to port 80, we have WP admin. Well, can we access that? Normal people cannot see these things, but we can because we're running tools against the website. And that's what we do as security people. All right, so usually I have something cached in my browser here. When you go there, it will actually redirect you like what it did here. It will say, hey, did you mean to go to secret? Something like that. So let me try that again. It only did that because I was signed in from my last session. And I usually sign out of that. So let's go to WP admin. And you get a 404. So you're like, what in the world is happening here? Well, lucky for you, you kind of know that there's something code /secret there, right? But WP admin leads to a 404. That is by design. This, what you're just looking at here, is what is called security through obscurity. And security through obscurity is when an administrator or somebody hides a port or a known URL. They say, well, WP admin is something that attackers always get to, so I'm going to hide it. And it's going to be a 404, meaning the page was not found. They change it to something else. They think that by doing that, they are hiding away from attackers. So WP admin in this case is hidden from us because somebody still believes in the idea of security through obscurity, where they change things. You will notice this with other things as well. If you look here, they did the same thing with FTP. Let me know in the comments here. I like people to interact with me. What port is usually FTP are running on? And look where they put FTP. 6777. This is security through obscurity, meaning trying to hide stuff from attackers from the normal place that they are from. There are studies out there that says that security through obscurity doesn't work because, well, guess what? I just found out you're still running FTP even though you changed it from its default port. So let me know in the comments, what is the default port for FTP? And because, I mean, we kind of, as security people, were expected to know these kind of default ports. So security through obscurity doesn't work because I found FTP. I also know that WP admin doesn't exist, but here's how I can find out. I'm going to open a new tab and I'm going to run GoBuster. GoBuster is going to go through the website and find any directory that was defined there. So I'm going to go through every directory that they have defined on that website because I'm interested. So I'll run GoBuster, which is my web enumeration tool, just to find out what directories are running there. If you're not running something on WP admin, which is our administrator admin page for WordPress, well, where are you running it from? I'll run GoBuster and find out what you're talking about. 38.28. So GoBuster will find it. Gaspar says port 21. Yes. So FTP is usually on port 21. They thought they were clever. They put it on 6777 while Nmap picked it up. They also changed WP config to a different port. So let's see if we can find it from here. 192.168, 38, not 28. This is how you know you're watching a live stream because we actually make real mistakes. Okay, so we're scanning here. What do you think is going to happen if I run a directory buster against a website? There's going to be a ton of traffic being generated to my website. So a host-based intrusion detection system that is running Bro or Zeek is going to have every connection logged. If I were, this is brute forcing directories. So let me show you what this looks like on the intrusion detection system. And to be honest, this is why I think that you should always join me every Sunday, because you can't, there is no way to know about this other than doing it the way we're doing. We're brute forcing some directories from a website. Well, what does that look like? Let's go and look on the network. I like to see what that looks like on the network because I'm using HTTP. And the easiest thing is, let's go to Kibana. Look at what happened here. Right away, we have a huge spike. This is from our Nmap and probably our GoBuster. So let's change this timestamp to last 1 hour. So it's not last 24 hours. Then let's refresh. I'll show you that the connection events increase exponentially, just like what we see here, because somebody's brute forcing you. So here's the last hour. This is when we ran Nmap. We were chilling out under what, 5,000 events. This is normal, 3,000, 2,000. We fire up Nmap. Guess what happened? Boom, 70,000. From 3,000 to 70,000 events were seen on my network. Nmap finishes. Now I'm running GoBuster, starting here. 57,000 events are being generated. If you are a defender, if I hired you and I say, hey, please protect my network, protect my website, would you be interested in knowing every time you go from just your regular 3,000 events, 2,000 events to 70,000? Will you be mad if I woke you up in the middle of the night and say, hey, please wake up? I see we're usually, 3,000, 4,000. Now there's 70,000 stuff happening in your network that you manage, that you're getting paid to do, or a network that you own. So this was Nmap right here. We saw that earlier. This is GoBuster, probably. Let's refresh this, make sure that it's actually running. How do we know? If I come down here, I can just pick on any of these. Let's say destination is 192.168, 192.168.30.246. That's the destination, which is our Kali Linux machine. This is our victim. What was this? Okay, Zeek, which is a tool that saw a connection. It saw a connection happening here. Where were we going? Or HTTP, great. What are we talking about? In this case, let's see. It's probably one of the brute forces that we're doing here. All right, I can't tell anything from this, but guess what? I'll let you in on a secret that you can see. Well, this doesn't make sense. I'm going to get a pcap. You can get what is known as a pcap file, which contains the actual transactions of what happened on the network. I can tell what happened from that connection. All I know is that it was a HTTP transaction. So I will click here, actions, pcap. This is one of the easiest things that you can do to really come to terms with what happened. Okay, our IP address was Kali Linux reaching out to our victim on port 80, and we did initiate the three-way handshake, sin arc here. But what I'm interested in, what were you trying to get? Oh, look at that. What is that tool that we just captured there? GoBuster. GoBuster got busted trying to bust some directories on a site. I apologize, I'm a dad. I make dead jokes once in a while. So GoBuster getting busted is a real thing here for us. GoBuster, and it even is a version of it. So what is GoBuster? Well, we're running GoBuster right now. We're brute forcing some directories. That's GoBuster. What does this tell you as a defender? Somebody's attacking my network using GoBuster, or somebody's testing my network. Maybe it's a legitimate user testing your network. So you should be able to tell what happened here. With this, let me stop GoBuster with Control-C. I think I have another one that was finished. Or maybe not. All right, this one will work. So GoBuster found, hey, in addition to the WP content, WLogin and WP content that we have, we also have something that stands out to me as an attacker, secrets. Well, what is /secret? I like secrets too, right? So let's go and find out. Instead of 44, let's see what secrets you have here. Oh, secret actually leads us to a login page. So what happened here is that administrator changed WP admin to be the secret, thinking that this will deter attackers from actually getting there. And in this case, well, we can see it. We also have a lost password here. which we can go to /lost password. And this will say, hey, what's your email address? We don't have any email address right now. So our best bet is to click the login page and go to secret. So we are enumerating WordPress so far. What I did here was I actually stopped this before it was done. We have a README. Let's check the README. Okay, so here's a README. Usually it's some installation instructions. That's not exciting. We can find some version information from that as well if we wanted to. But this is just showing us, hey, we can actually enumerate a WordPress website and find out what it's actually doing from there. What I didn't show you here, which you will see after if you let GoBus run all the way. Or is it here? Let me see. Is you also have /tasks. So let's minimize that. Let's open our browser. So we also have /tasks, which is something that GoBus will find. It says, hey, by the way, hello, Jared Lee. This is information disclosure. You should not have personally identifiable information for your administrators or anybody on a site that you don't want to. In this case, especially if it's like some tasks, this is classic CTF information. Nobody actually in the real world does this stuff. Nobody in the right mind, let me say it that way. Do you manage the office as admin when, since the admin is away for a few weeks? Great. So Jared does have some administrative rules. Admin has created other temp account for you and details in pickup.ng file. So if you look during the, if you look in the results here, after a while, if you didn't specify any extensions, you'll notice that there's a jared.pickup.ng, just like this. No. Pickup.ng, one word. And when you do that, it will bring you to a pickup file. This is why I chose this machine, because it's very exciting, right? Now we are like, okay, so there's a pickup file for a user called Jared. Forget the CTF stuff, it might be annoying, whatever, but we get to read a pickup file. So let's click OK and open this file. And when you do, you end up with a file like this. If you have never seen pickup in your life, you're like, what are we talking about here? We open pickup in Wireshark, right? And in Wireshark, we see everything. This is a pickup file that was created for Jared, the user. And in this case, we see TLS traffic, DNS traffic, TCP traffic. My Wireshark is kind of color-coded here from my view. I also have my, I think I have my name resolution changed. Resolve physical IP, no, I actually don't have those. But I have colorize packet list checked here. That's why you see yellow for TCP and some HTTP here. Well, I'm interested in some interesting stuff, right? This is overwhelming. Put yourself in my shoes. I'm faced with a pickup file where I need to see if people were logging into a website. So I might not be as excited about, things like DNS and everything. Let me see, what were the post requests that were sent? If they were sent in HTTP, I'd like to know about them. So http.request, method of post, in this case. When somebody's signing into a website, let's go back to our website here. Okay, let me close this one. If you go to a website, in this case it's /secret, and you put a username of admin, password, like that, and you hit login, that is called a post request. I am posting something to the website. I'm saying, hey, website, can you let me in? In this case, this website says, hey, be warned, we are monitoring you trying to sign in, and you have 2 more attempts before we lock you out. That is a post request. How do you find a post request? If you are given a packet capture, http.request method equals to post. So this means that this is every time a user tried to send information to that website. In this case, the website is on 192.168.3.3.11. This is a packet capture from a snapshot in time somewhere. So what I'm interested in is the HTTP traffic here. In fact, I see that login was Jared, no password. This is again the implications of HTTP traffic. If this was HTTPS, you won't see a thing. It will be encrypted. It will be a bunch of jeopardies. HTTP, now we see, oh, they posted username of Jared, no password. That's 1. Next, they tried Jared. That's 2. Next, Jared, password is space Jared. So this person was trying to sign into the website. They did it again. Jared Lee with capital L-E-E. Well, I'm creating a list of possible passwords. Put yourself in my shoes. You see a bunch of all this noise here. Kind of obvious and useless. Jared Lee, Jared. Then you go to the last one, and the last one says Jared Lee, and the password is no brute force required, and it looks like it's a complicated password. Be reasonable with me. Isn't this the obvious choice to try first, other than the other ones that sound obvious? So to me, I'll go with Jared Lee, and this is the password. To make it easy for us, I made a list of all the passwords that we're looking at here. So let me just paste them down here. So this is what it was. So we're going to try the last one, Jared Lee, and this password here. And where are we trying it? Right here. Let's see the password that we're putting. There it is. All right, so we are in. If you have never managed WordPress in your life, this is probably something new. But I'll tell you right now, this is not good news for an attacker. This is a regular user. This is a regular WordPress user. You're not an administrator, because this does not look like a WordPress admin profile. So if you go to anybody's WordPress out there and you create an account, you end up with something like this, especially if they make you like an author or something like that. So this is not exciting. I am not happy that Jared Lee, in this case, is not an administrator, because if they were an administrator, I can mess with the website. Now, well, not here. I can go to the post. And here's something. Keep this secret. Oh, yeah, it's a draft. Oh, maybe I like that. I don't like to keep secrets. I like to tell everybody. So let's let's see what we're dealing with here. All right, so while this is loading, let's also see our intrusion detection system. What did we see? Let's go to our alerts. All right, so far, as far as our warnings are concerned, I don't see anything that we would have triggered. but we are monitoring everything on the website. So if you wanted your website to be monitored even better, what you can do is have WordPress monitoring enabled on that website. This website does not have WordPress monitoring enabled. We're monitoring the system. If somebody messes with the system, we detect. WordPress, not so much. But let's close this because we're done with Wireshark. But here's our keep this secret message. What is that? What format is that? It doesn't look like base64. It really does not look like base64. And base64 is a way of encoding. Usually base64 ends with this. So I'll try it anyway. I'll be damned. It is base64. So I guess I didn't think this was base64 because I usually know that base64 I get the equal signs. But I don't know. I echoed it to base64 and sure enough, look at what happened here. Always super secret password base64. It says invalid input. I don't know why it says invalid input like that. Somebody let me know. Base64 decoded it, yet it's complaining about it. So I don't know. This is interesting. So is the password this one? Or does it include this? We'd have to find out what in the world this is. But I'm going to document this in my notes. I'll put it as part of my documentation here. All right. Then I'll also put the whole thing, just in case. All right, so we found it's some super secret password. For who? We have no idea. Well, that's not cool. We don't like that. So far, we know that Jared Lee is kind of useless right now, as far as the website is concerned, other than this super secret password here. So let's log out. Let's go back. Do we have our GoBuster results somewhere? You know what? Forget everything. Let's go with FTP. Now that we have Jared Lee's username and password, let's sign into FTP on port 6777. I'm surprised we didn't even try that. I like FTP better, so let's sign into that. FTP 192.168.38.128 on the port that we actually found. This one, you have to specify the port number. Jared Lee. The password that worked on WordPress is what we're going to try here, because people are people. They will do password reuse. So let's copy Jared Lee's password that we used earlier, because people do that. Let me make sure that I'm copying it correctly. Give me 1 second. Oh, let's try something else actually. Let's use Jared Lee and use the password that we just created right now. The other one was okay. Okay, it says incorrect. By the way, every time we do this, we should have our intrusion detection system complaining. It should be complaining. So let me figure out why I cannot get in here. I'm actually not copying the password correctly. Okay, let's exit. Let's do it again. I'll paste the password again. There it is. For whatever reason, my terminal wasn't copying. Okay, let me exit out of there. I wanted to show you the password that I'm typing here. It's Jared Lee, and this password. All right. Hey, you gotta copy it a couple times just in case you mess it up. So it wasn't copying it for me, so I had to paste it here and copy it again. I think there was a space here. Weird password stuff, but we're in. So when you get in FTP, the first thing you do is dir when ls minus l, and in this case it's like let me go one direction down. ls minus l. I see a directory called Jared Lee. I have a problem. I don't like to put it in my root directory, so I'm gonna have to change this and do it again. I like to do it inside of my Ganana machine, so I can download everything and put it in this directory. So I'm going to redo that. So let's exit out of here and paste the new password. I just want to do it in the right directory so that it's easier to keep track of everything. So if you do it in here and you download files, then they'll be in here. They're not in the main root directory. All right. If you do an ls minus l, cd dot ls minus l, okay, get. Can I just get a directory without any special keys? Because this is a directory, I want everything inside of it. Jared Lee. Okay, I need a switch. Or I need something to say, hey, get everything in there. ls minus la. So la gives me hidden stuff. I see bash history. I like bash history. Backups. Is backups? Backups is a file. So I downloaded backups. I would also like to get bash history. All right. Watch what happens. When I exit out of there and do an ls minus l, a because those files are still hidden. They're still here. Let's start with bash history. All right, so they were switching users here. I like that. And here are the permissions that were given to the backups folder. The cat, the Etsy shadow. I don't see passwords, but bash history. Oh, wait a second. Okay, I don't see passwords. That's what I'm looking for here. I don't see passwords yet. So I'm going to move on. ls-l. Let's go to our backups. We store these from the thing that was there. What is this? Well, in my world, it's base 64, else it's not. All right, so we piped some gibberish stuff to base 64. Based on how we saw last time when I was like, hey, it's not base 64. It doesn't end with the equal sign. Well, these people like base 64. So this is a base 64 encoded Linux hash for a user called Jivan. So what can we do about that? Let's output it to hash.text. All right. This is a format that our good friend John understands. So let's try to crack this hash using John in a simple way to just see how it works. And in this case, if you forgot how to use John, it's not my first rodeo with John, so I guess we're going with this format. And we're saying, hey, by the way, John, use the same word list that we know. It's just a hash.text here. So can we crack that? Okay, let's start it again. So John is going to try to crack that hash for us and see if we can actually find what's happening with it. So it was something encoded, and here it is. The user is Javan. Hannah Montana is the password. Okay. How do we use this Javan Hannah Montana username and password? Let's go and we could have signed into WordPress. Okay, it's trying to sign out. But we can also go to a /php my admin site. You see this from your GoBasa results, which I might not have shown you earlier. We're going to use the same username and password that we just cracked here. So php my admin is just a WordPress website way of dealing with things. In this case, let's try the Jivan user. Can we get in here with Jivan and Hannah Montana? And don't save that. No, MySQL is like, nope, That's not gonna work. Okay. We do have another username and password. That's what we know for now. Let's minus LA. So we store the backups. We store history.txt. And so far, we actually haven't been able to do much with that. So let's go back to our FTP. I think we didn't enumerate it enough. Let me find the username and password here. So the credentials that we found from the FTP don't work. But we found something. Maybe I need to steal more stuff. So here's Jared Lee. Back in again. ls minus LA. Okay, that was just the user profile, and I did a cd dash and I did an ls minus LA, and I was like, oh, let's steal everything from Jared Lee. We don't have any SSH keys here, so Jared Lee is not helping us that much. Let's keep going. Let me see if I can do it clear. No. Okay, let's keep going backwards, because remember we're changing directories backwards. ls minus LA. Aha, now we're talking. Let's go to home. ls minus LA. This will tell us how many users are there, or Jared Lee exists as a user. So that's really not going to help us that much. Let's see where else we can go. City. Okay, let's look at our WordPress. In WordPress actually keeps user configs. It's what? Verb, www, HTML, or something like that. Let's try to go there. Where is the website here? Okay. Here's the backups again. Or is it the same? Let's minus away. These backups don't look interesting. App extended to GZ states, whatever these things are. Okay, I was trying to steal all of them, but forget them. I'm on a mission to look for WordPress. Where is WordPress? Where do we keep our WordPress? I'm curious. I thought it's in var. Let's go back here. ls minus LA. What you got? This is the root section here. Can I? No, I can't see squad for root. I can try, but you can't see anything here because of these permissions. So we might as well save ourselves some time. If it's not in etc, this is where you can also find your website. BitMoney is, that's, oh yeah. So this tells me two things. We're running containers, and we also, this is like a LAMP website or XAMPP website or any of those pre-packaged websites. So they're running BitMoney. Container D also runs containers. Okay, so I think my WordPress is in here. ls minus LA. So you got BitMoney instead of BitMoney. Interesting. That is interesting. This directory here won't let me in. Where am I? So I'm inside of OPT. And I can't see anything in here. I guess we're everyone, so we got no read permissions. Bitnami, I'm so dumb. Thanks, BT. I am really dumb. If it sounds good to me, that's how it's going to go. Okay. All right, so we are in. Thanks, BT. So here we go. We have used WordPress. They're using Let's Encrypt, which is a free SSL traffic website out there, which is good. But we're not interested in that. We're interested in their WordPress location here, because that's actually going to help us with stuff. In this case, it said to use WordPress. So let's see. Do we have an apps? Yeah, we do. So this is where we keep WordPress. PHPMyAdmin, I like that. So this is how you can know that you have a PHPMyAdmin. But WordPress, inside of WordPress, we are looking for WP admin. Let's -LA. WP config. So we have a conf here. And that's another one too. This one talks about, who can access what, or here's some credentials. So this is not the default. So it could be any of these. I'm going to try to steal this. But I think if I Google it, I probably know where the wp-conf file is. All right, I stole that one. This is a directory. Let's -LA. It makes sense if it's a configuration file, it should be in the conf. Now, this is the HTTP access file. So it should be then in the htdocs. Let's -LA. All right, bingo. All this work just to find this file. This file better be good. I'm only interested in this one. You know what? I should have stolen the whole directory. By now, I should have literally just downloaded the whole thing to my Kali Linux. I shouldn't have even wasted their time. I should have just stolen it and then searched through it. But okay, we stole the one file that we were after. WP config. All right. So here, we also saw that we have PHPMyAdmin. So we are going to, is it db underscore something? Or just db? All right. So define here some authentication keys. All right. I forgot what the files are called. So I'll search. Where do you say database here? Okay, define database that database uses BN WordPress. Okay, let's steal that. I'm missing a B, but that's fine. So forget Jivan. Well, let's not really not forget VN WordPress. Then let's put the password. DB password, whatever this number is. Let me make sure that my copy paste is actually working. So it was capital DB underscore password. That's what I was trying to copy earlier. We copy it to a different text editor and make sure that it's actually the correct stuff. All right, let's sign in into the database. Forget this one. Remember this one. Don't save the password. So what are we doing here? Why are we doing this? Remember, we found out that in our WordPress, our Jivan is not even a user. The other user that we found was not helpful. So now we just need to break into the database using this password here and try to see, can we see interesting information? So it's a Bitnami WordPress. Where does WordPress keep their users is in WP underscore users. So I'm just going to go straight to WP underscore users. I got me Charlene Walker. Charlene Walker and Jared Lee. Jared Lee is not an admin. Then Charlene better be an admin, or else this thing doesn't have an admin. So I can edit. I can crack this password the same way I did earlier with John. Or I can just change it. I think let's change the password the way that way we can actually learn something new. Let me share with you. Here's a link. It's in the comments there. But here's how it works. If you see a WordPress website and you can actually just get to the database, just Google WordPress password generator. Input a password that you want. Password. Tell it you're not a robot and hope it believes it. It believes you. Generate the hash. You have two options. You can run this SQL query in your WordPress instance, or you can just take the password hash, copy it, come here and just paste it. In this case, you notice that, why is this different? It shouldn't be different. I think I typed the same password last time as this time. So let's go back. I don't like what it did there. Okay, yeah. Let's just take this password here and update it. We don't know what Charlene's password was. Put it there. All the way at the bottom in PHP go. Charlene's password has been updated. So now let's go and sign into WordPress. Secret. I think that's where we were. We like Charlene Walker as a username. Okay, this thing is gonna have to remember me when I sign out. Log me out. I guess I have to do it a couple of times. There we go. Okay, now we're signing in as Charlene Walker and password is password that we just reset. Like that. If it doesn't work, that means that I didn't reset it to the correct thing. Alright, so we are in. Please notice on the left side here now that Charlene Walker has more stuff happening here than what we had before. What this tells us is we are actually in as an administrator because we can change the appearance of the website, update the themes. Well, there's one way that is known and tried, and most of the time it works, is the plugins. You can trick WordPress into installing a malicious plugin and get a reverse shell. So that's what we're going to do. Go to plugins, add new. Try it again. All right, so here is our plugin section. Upload a plugin, and I'll let you in on a secret. This is something that I think after you've been doing CTFs for a while, you kind of know right away that, hey, I see WordPress, I do plugins. One of the ones that you see, if you just Google, hey, WordPress malicious plugin to get a reverse shell, is this thing here. WP pawn. So what you can do is you can just right click and git clone this thing if you want, or just clone, copy the Python script here. I would click on it and just raw, then just copy the whole thing. I'll probably just do something like this. Now get me out of here. So how do we break into WordPress? We're going to actually just create a malicious plugin by running Python WP pawn, just like this. It says, hey, we can run it this way. This way we can actually have a MS of Venom reverse shell. Today, there's so much that we're covering. I'm going to use it exactly the way it is. So copy the exploit, upload it as malicious.zip, and off we go. So let's go back to our machine. Escape, quit. You can do an ls. Here's the wp pawn .w. So the command that you can run is wget, and go back to your browser. Open this one. Remove this gibberish here. Copy. This is the command that you run to get this script here. This will probably hang for a little bit. Or in this case, it's complaining about a bad request. I think, it's because I have this silly Google Translate thing here. But you get the idea. If you find the original Git repo, just run it that way. Then now let's go ahead and just run our Python script. According to our documentation, this is how it should run. The IP address needs to be the IP address of a Kali Linux machine, so 38.246. Yep, 246. So we go back here. And we're like, okay. We need Python, and in this case, I'm running Python 3. So this will start an MS of Venom it will also generate a malicious WordPress plugin that we can upload. So I'll let this one run. Let's go to our upload here, upload plugin, because as soon as it's done, I'll show you the plugin that we have. Browse. This is how you attack WordPress, by the way. We've done this, I think, several times on this channel. Malicious.zip, that's what you get. Install now. I didn't make that one up. It actually tells you here, like, hey, by the way, you get a file called malicious.zip. All right. So the plugin has been installed. Let's see if our payload actually succeeds here. Because we just need to make sure that once it's done, we can trigger a reverse shell. All right, there we go. It says, hey, how to get triggered reverse shell? Go to this location. Well, we're going to go to that location. Copy that link address. All we have to do is remove the target and put our IP 192.38.28. Okay, before I hit enter, I need to make sure that this is actually running. My MS of Venom is actually listening. So let's give it a second here. And while it's coming up, oh, what happened? Whatever happened to Security Onion? Aren't we supposed to be detecting stuff? What's happening with Security Onion here? Oh, I see some interesting stuff. Authentication success vs SFTP 10 times. Remember how many times I tried to get into that FTP server? Oh, there we go. So our intrusion detection system observed us trying to get into FTP. This is our Wazuh agent detecting us. And it says we were successful in logging in. Okay. It saw Jared Lee signing in, according to here. So all those success or failed attempts that we did for FTP, at least they were logged. And in this case, we can see that. So if you try to sign into FTP and you're monitoring that FTP using an intrusion detection system agent, like Wazuh in this case, you will get detected out of the box most of the time. We might have tried anonymous user here, and this probably didn't succeed. All right, so we got caught trying to mess with FTP. And why is this MSF console not starting? Let's give it a second. It has to start. If it keeps hanging here, I might have to figure out why it actually did that. Sometimes you need to run it without sudo privileges, which in this case might be the case, but let's clear that screen because we're good to go. Now I'm regretting saying I wanted to start a handler for me. Maybe I shouldn't have said that and just use netcat. But let's let it run. Or maybe not. Let me make sure the port is not actually listening. Okay, it's not. 192, 168, 38, 246. Let's remove the old one. And do it again. Then we'll find out once it's done. And that's just how to get a reverse shell. Then we'll be able to escalate our privileges and we'll be in business. So this should not be we should not be here for too long. All right, so we did write a malicious file. Let's go back to our WordPress and clean it up very quickly. Just in case we have a ugly plugin that we have in there. Okay, so we need to remove this one. This is the one that we added earlier. Let's remove it, make sure that, you know, we don't run into problems. Let's delete it, apply. Yep, I want it gone. Refresh. Seeing if it's still starting my Metasploit. Looks like we're back on the same thing. Why is this thing not starting? $246. All right, if it doesn't start in the next minute, I will actually have to move it from the root user to just a regular user. I think that usually works. New tab. Okay, so in my downloads here, let me remove malicious.zip. Yeah, there we go. Okay, I'm going to run it without the root user privileges, because I've seen Metasploit pulling moves like that, where it doesn't like to be ran as root on Kali, except it ran earlier, so let's copy WP. Downloads. All right, so we copied it to our downloads. Let's go to our last section here. We have our WP pawn right there. Great. Now let's run it. Or maybe we just need to give it some time. We're just trying to generate a malicious WordPress file here. So while it's loading here, let's go back here. Let's refresh. Let's make sure that it's not there. Let it finish. And here we are launching our handler. All right. If it gets stuck here, I have no idea why it's doing that. Then we just have to get our reverse shell a different way, which we might have to create another PHP console, which is just fine. It doesn't really have to be the same. I tell you, being an ethical hacker is not supposed to be an easy thing. It seems to work without root admin on Kali. It's working now. So this is why I say this is no BS attacking, because you get to see things working in real time. So if your MSF console doesn't start and you're running as root, try without root privileges. And here's our malicious zip. Let's open that, install it right now. We would like to activate the plugin, please. Yeah, and I've seen it where it doesn't work without with the root privileges. Okay, then if we visit here and hit enter, this will hang like that, and voila, we should have a reverse shell right here. Can I do it clear? No, clear. Okay, give me a shell. Here's what happens. If you say shell minus t, you actually get a nice shell like this. If you don't put this minus t, you do not get a good shell. I learned it the hard way. Okay, and this is a nice shell. If you do an ID, you're in here as daemon. Well, we're not too excited about this daemon thing, because if you do an from ID, you're only member of the daemon group, and usually daemon is like www data. This is the most useless account you can be in here. You cannot do a sudo minus L because you don't even have a password. But lucky for us, from earlier, we found out that we had a user, Jared Lee. We also have a user, Jovan. But let's try Jared Lee first. And the password for Jared Lee, which I saved earlier, so that's the listener's command to switch the user. Come on, give me a break. It copied everything that I had saved. And by the way, that should be logged. That should be logged. So if we go to Security Onion, we should see us failing to switch the user right there. That's a good intrusion detection system. All right, switching user succeeded. Well, I don't want to be a liar. Let's go back to Security Onion. Switching user should be something that we log. Remember, according to our job description, security events and log management system, you need to have experience with that for these employers to even consider you for an entry-level job. So let's see. This one. User missed the password to change ID. What does that mean? Well, we'll drill down. This is intrusion detection system on steroids right now. Failed to switch user to Jared Lee. I didn't make this one up. I knew it should be logged. And this is from the var log auth.log. So anytime that we fail to switch a user, it should be an offense that's logged. This is how you learn cybersecurity skills. You kind of know, like, okay, var log auth.log. Do you want to detect every time somebody fails? Maybe, maybe not. Do you want to do this for all 10,000 computers that you manage? Maybe, maybe not. Depends on your employer. But in this case, we are, because we have one system to monitor. All right, so sudo -l. What can generally do here? Okay, don't do this. This is cheating. Jared Lee has pseudo privileges. I gave Jared Lee pseudo privileges earlier as part of persistence. Your Jared Lee might not have pseudo privileges, so we're going to assume we didn't see this. But if you switch to user here, this machine will be done. That's not how we should do it. But Jared Lee, it's got pseudo privileges here. Let's do an ID. Jared Lee only belongs to Jared Lee's groups. But this is not just what we had. We also had something else. We also had another user. Do I still have them saved somewhere? No. We also had another user. Let me find them. Because I documented that user that we found last time. This is why you want to have your documentation in order. We also had another user called Jivan. So switch user. And the password was Hannah Montana. That's the one that we cracked earlier. Like that. Sudo -l. Well, Javan doesn't even have any pseudo privileges. So forget Jared Lee. Let's go from Javan. That way we can actually privilege escalate from here. Well, Javan ID, what do you belong to? This is where the money is at. If you see a user that belongs to the Docker group, you are in luck because there are Docker privilege escalation tools out there. The idea here is a normal user should not be part of the Docker group. This should be a system account or a service account that you're using to manage Docker that belongs to the Docker group. The fact that Jivan belongs to a Docker group is a problem. I cannot emphasize that enough for us here. If we're trying to learn something from these live streams, this is one of those things. A normal user, they should not have any business in here. If you wanted some special permissions, say for Docker management, you should add them with those permissions defined to the Docker group. But in this case, just adding a normal user to the entire group, your loss. So we're going to go to home. Notice that this user Jivan doesn't have a home directory. That's fine. Maybe, you know what? Jivan, I don't know how this even happened. The user ID is 1003 and the group ID is 1005. Usually the user ID and group ID match, but in this case they don't. The fact that it's above 1,000 shows me that this is probably meant to be a service account because it also doesn't have a home directory in the Linux home directory here. So they thought they were smart here by having this Jivan account as a service account and add it to Docker. However, this account does have a password. So this should be a no password account. If I were to say, let's set it up correctly. This is also why we say, we talk about the right ways of doing things. If you have an account that acts like a user account, but it's not really a user account, and it gets access to services like Docker, people like myself are going to get excited about that because if somebody belongs to a Docker group, guess what? I have another GitHub account for that. Just go and type Docker privilege escalation Linux. You probably see yourself on this Git repo. I actually have a translation here, Google Translate, so don't mind my links. But this is what you see here from, I want to make sure that you see, is Christopher Staley, Docker root, please. All I have to do It's literally saying, hey, Docker, which one do I want to run? You can run any of these Docker commands here and you end up in root. I'll run the last one. And I'm curious what this looks like. This only works, please remember, this only works if the current user is part of the Docker group. And what this is going to do is it will give us access to a Docker container with root privileges, but this is the fun part. Here's a blog post for more detail. This Docker container is going to come pre-bagged with permissions to read. That means that this container is going to mount all the file system stuff inside of itself. So it's going to mount everything with root privileges, by the way, so that you can access everything on the main system from the Docker container. That's a big problem. And if you are interested in that, here's an article that you can read. Because I think this is a very interesting thing to happen. And it happens, it actually works. This is not the first time we've actually done this on this channel. But this will launch a container, drop me inside of a container, and I will have root access inside of the container and be able to read root access level systems with that container. And I'm curious, well, where is our intrusion detection system when all this is happening? Where is Wazuh? How does Wazuh see this stuff? I mean, anybody who is in security will be like, yeah, I want to know that. And I really want to know that as well. So let's run that and see what happens. Or did I run the wrong one? Okay, it actually did it. It's exactly what it looks like here. So you belong to the Docker group as a normal user. Now you can say, where am I? I'm root, but where am I root at? Uname -a. I'm actually inside of the container here. This is the container. This is not the main machine. You are not root on the main machine. However, by doing this, you mounted the root file system into this container. So it's like having a USB. You plugged in the whole computer as a USB into this container. Now you can say ls/root. This is actually the real machines/root. Cat root.text. /root. root.text. And this is our root flag. I don't know if I'm explaining this correctly, but there's other machines like I think it's there's other machines that I've done this where on this channel. Like, I think this is the fourth or third time where we actually got root from the container without actually messing with the root system. So how do you gain persistence from here? You can cat /etc pass wd, and now you see all the password, right? You can cat /etc /sudoers. This is how you gain persistent. Remember that Jared Lee user? I just echoed echo, and I echoed this text. In this case, I'm not doing it for Jared Lee. I want to do it for... come on. Give me a break. I want to do it for the other user. I like to do it for Jivan. So Jivan is going to be a sudoer right now. So let's create our command here. I can even say no password if I wanted to, but for now this works. That looks good without the capital E for echo. And by the way, if you mess with the sudoers file, you're done. You're not going to be able to run your sudo commands again. So just know that if you mess with the sudoers file, it might be the end of it. So make sure whatever you're putting here, the syntax matches, because I've messed with the sudoers file before. It's not fun. You can fix it, because you need the original root password and you need to be local. Just be aware when you do privilege escalation or persistence the way I'm doing here. So cat such as C. Let me know in the comments if you ever messed with sudoers file and it really messed with you. So now Jivan, who did not have root privileges, now has root privileges. That means that I can come back here, SSH as Jivan, and have root privileges. I can modify anything on the main system, but from now, I'm literally in the system. Okay, sudo minus L actually. Since we added Jivan to the sudoers file, let's see if Jivan this time has the sudoers privileges. And guess what? We can. How do we do that? Sudo su. We are now root on the system. We can actually run anything we want. So we went from being root on the container, using the container to make ourselves a sudoer to be root now. Then we can create another user. Now we have a user, hacker. And here is hacker sitting there with bin bash access with a user ID of 1000. And oh yeah, these user IDs are off. I hate when this happens. This should match, please. The user ID and the group kind of are mismatched here. Anyway, this was how we do it. The final part that I wanted to cover is, well, we just escalated our privileges using Docker. We can't just ignore that. We have to talk about that. We mess with Docker to modify root level file systems, especially like the sudoers file and things like that. So what did we see? Did we see it on the network using suricata and zeek? Did we see it using the Wazuh agent? Which is running. This is the agent that I'm talking about. This is a host-based intrusion detection system. Did you see it? Well, let's go find out. I got a lot of questions just like you do, and we need answers. Like we need answers yesterday. We can't go to bed without knowing those answers. Well, first I'm going to say, you know what? Let's just filter everything by the Wazuh agent. Let's also just see a bunch of alerts here. Let's go back here to our custom intrusion detection system. This is just me getting ready to view all kinds of alerts right now. I want all alerts, whether they were caught by suricata, whoever, everybody who saw something, I want them to tell me about it. You saw something? Say something. Okay, we saw that FTP signing in failed, and we saw FTP failing, okay? SSHD, we saw this earlier. Successful sudo, all right, sure. New user add, let's start there. We added a user called hacker. This is an intrusion detection system. This should detect what happens on the host using a Wazuh agent. We ran a command called user add. What was the name of the user that we added? Hacker. Let me know in the comments why would you care if a new user is added to your system? Why is this even worth talking about? This is from the auth.log. Why do you care? Let me know in the comments, but let's make this a little interactive as well. But while this is happening, I would like to keep looking at this stuff here. Okay, so we do have some of those things happening here. I'm going to check for the Wazuh specific alerts or the OSEC. Oh, this is an interesting file too. This is a UFW. This is the local firewall which blocked an incoming connection from a PC. But I want to see traffic that says, hey, something funny happened with Docker. That's really what I'm looking for here. So bear with me while we hunt for this stuff. Forget last 24 hours. I want last hour. Okay, let's refresh that. Oh, there we go. I knew something funny was happening. Let's take a moment for a second and pause. What's up with this? Who was setting up an interface in promiscuous mode? That sure better have something to do with Docker when we mounted a new container. Please bear in mind that this is not just unique to when we are doing privilege escalation. This might be normal depending on how you're launching your Docker containers. In this case, we launched our Docker container with privileges of the root user. We mounted everything as a root user. And one of the things that the tool that we used, I want to make sure that this is clear. The tool that we used entered in promiscuous mode. So let's drill down. Why did we enter in promiscuous mode and what was happening? So the agent IP, this is our victim machine for sure. And we got detected by the Wazuh agent. And we know in order for us to be able to do what we did, we generated this alert that says we created an interface in promiscuous mode. So what does this say for us as defenders? If you are running Docker containers and everything is happy and jolly and nothing is bad happening, and all of a sudden you get an alert that says, hey, by the way, Docker is now has an interface that is in promiscuous mode, you know. This tool here, not that one, the other tool that we looked at, this one, does launch this Docker container in promiscuous mode, meaning it will listen, it will put your interface in a, I think this is a bridged mode for the interface, where it's just bridged, which sometimes you don't do it that way unless if you're sniffing traffic, unless if it's an intrusion detection system. You never bridge the interface in promiscuous mode like this one. So this is an indicator that someone is doing privilege escalation if your Docker containers don't have a business to do that. All right, so in addition to that, other indicators like new user being added, a new group added to system. Let's check this one. Let's drill down. This is a medium alert, so it's kind of interesting. Wow, this is just when we created a user hacker. It also created a group ID of 1006. So it's an indication that somebody's trying to do persistence on your system. Let's see what else we can see here. We done it. First time sudo. Oh, Jared Lee got caught switching from regular user to sudo. Significance here, it's a first time sudo command running. This is an indication that either one of your administrators did create an administrator account with sudo, or in this case, it's a first time sudo file. So those were the indicators that I wanted to share with you, and I really appreciate you sticking around until the end. And thank you very much for being here tonight. If you have any questions, please make sure to put them in the comments. But this was a very exciting live stream. Kind of got long because we actually had to do everything by hand. Otherwise, thank you for being here, and I hope to see you next time. Thanks.